Hey, what's going on everybody? In this video, we're going to explain the calloc function in C. Calloc, it's short for contiguous allocation, but I like to think of it as clear allocation. What it does is that it allocates memory dynamically and sets all allocated bytes to 0. Malloc is faster, but calloc leads to less bugs. With calloc, there's an extra step. We set all allocated bytes to 0 to effectively clear it. And there's two arguments we pass in, the number of elements and the size of each element. With malloc, we pass in a number of bytes instead, but they both behave very similarly. Here's how we can use calloc in C. We're going to include the following header file. Include stdlib.h. Let's pretend that we're playing a game. There's a number of players, but we don't know the number of players until the program is already running. We'll create a prompt to ask the user. We'll create a variable of int number for the number of players. I'll set that to be 0 right away. Then we will ask, using a printf statement, enter the number of players, :space, and then we will use scanf to get some user input. Scanf %d, store this at the address of number. Here we're going to allocate some memory dynamically. We'll start with malloc, but then convert it to be calloc. We'll need a pointer. This will be a pointer to an array-like data structure where we're going to store integers. The data type is int. This is a pointer. We need the dereference operator. We'll create an array-like data structure named scores to hold all the player scores. Equals, we'll start with malloc. For malloc, you pass in a number of bytes, for example, 100 for 100 bytes. But we're actually going to calculate this. What is the number of players we have times the size of what we're storing? We're storing integers. In most cases, an integer is 4 bytes. We need the size of an integer. If we have 10 players, and the size of an integer is 4 bytes, well, 10 times 4 is 40. But we'll calculate that. Now, if we dynamically allocate some memory, we have to free it when we're done with it. Call the free function, pass in our pointer of scores. That will free the memory. Also, take our pointer and set it to be null when we're done with it. I like to think of dynamically allocating memory like renting an apartment. We're renting space in the heap. Once we're done with our apartment, we have to release it. We have to give it back. And we're returning the key to the apartment. Both of these steps are very important. As good practice, we're going to check to see if our pointer is null. If our pointer of scores is equal to null. If for some reason we can't allocate this memory, it's going to return a value of null. If you dereference a pointer that's null, it can cause a segmentation fault. If our pointer of scores is null, then we will print the following. Let's say memory allocation failed. We will return an exit code of 1 to exit the program. After this if statement, let's see what's within this memory that we've allocated. And there's a big difference between malloc and calloc. Let's cycle through this array-like data structure. Int I equals 0, continue while I is less than the number of elements we have. If we have 10 players, we gotta cycle 10 times. Increment I by 1. During each cycle, I will print. We're displaying an integer. I'll separate each with a space. With our pointer, we can treat it like it's an array. We can access it by index. Display what's at index I. Let's see what's within this memory that we've allocated. Let's say we have 10 players for our game. Well, here are all the scores initially. They all contain garbage values, because we didn't clear it out. Before accessing these elements, if we assign all of them, it won't lead to unexpected behavior. So another option is to use calloc to reset all those scores. Replace malloc with calloc. but we pass in 2 arguments. The number of elements, comma, then the size of each element. Now let's take a look at our scores. Enter the number of players. We'll say 10 again. And all the scores are 0. And then if you would like, we can enter in some scores. After our if statement, we'll create another for loop, and I'll just copy the one we have currently. We'll say enter score number %d colon space. We'll insert I, whatever I is currently. I is going to be 0 during the first cycle. Enter score number 0 might not make sense to a user. We'll add an offset of 1 when displaying it. And then we will use scanf to get some input. We're accepting an integer at the address of our pointer to scores at the index of I. We'll insert a value during each cycle. And then let's run this. Enter the number of players. I'll say 10. Enter score number 1. We'll say 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And here are the scores. Alright everybody, that is the calloc function. It means contiguous allocation. It allows you to allocate memory dynamically and sets all allocated bytes to be 0. Malloc is faster, but calloc leads to less bugs because we take an extra step to 0 all the bytes. And well everybody, that is the calloc function in C.